Okay, here we go. Let's see, not right, let's go here. And let me go ahead and change that up. PS1 is your prompt, so if I come over here, come on. So this, let me add a new line. Yeah, there's some stuff embedded in there. Let me do this. Let me put it into file.bash. So this is what is inside of PS1 by default, and that's what's producing this stuff. So that would be the user, the @ sign, that would be the host. I'm a little unclear as to why this is going down onto another line. That's why I tried dumping it in a file. Let me see if we do an optical dump. Yeah, it's a new line. Then the -w would be the current directory. And then of course the other square brace, the $sign, and then there is, that's it. There should be, I'm surprised I'm not seeing a space here, because we are getting a space here. Probably because me just printing it out, it's not getting quite what the original was. Let's see if we can find the original. Let's see, let's go to Etsy skeleton. Alright, let's look at the bash RC. Yeah, you can see it right there. So there's the actual definition of it. And then the question is, where do you get these codes from? I believe that probably it's going to be in bash. Oops. That's what I meant to do. Let's see if I look for... C prompting. Prompting. Alright. When executing interactively, bash displays the primary prompt, PS1, when it is ready to read a command, and the secondary prompt when it needs more input to complete a command. So you all familiar with that if you do something like echo, quote, Todd, and I haven't closed the quote yet, so this is the secondary prompt. So anyway, this is kind of giving you what all those shell variables are, and then here's, so all these are defined by the shell, right? So you can go ahead and customize your prompt however you want. I got to sit down and read through this and figure out so that I don't have to keep, and it's clear what I'm doing is that this is just taking too much real estate on a zoomed in, where I make the font big and then split the screen. So I should just figure out something that's small but informative, maybe just like the current directory or something like that, and a $sign would be good. Anyway, a project for another day. Anyone know what Etsy scale is? The skeleton file. Okay, let's move on. All right. Yes, that's certainly what it means. Let's see. If I do a
base for your MRC and bash proton, something like that?
Right here. So this is user add. Create a new user or update default user information. So this is adding a new account to a Linux system. And the skeleton directory, which contains files and directories to be copied into the user's home directory when the home directory is created by user add. So if you're doing system administration and you want to ensure everyone has the same stuff, when the users are created, you dump it in there. And so when if I do an ls, there's nothing there, but that's because it's all these hidden files that are being copied. I think I added the MRC here. Yeah, this is my stuff, so there I am being naughty, disabling the arrow keys.
So did you edit that yourself?
The Etsy scale?
Yeah.
Yeah, so right now I'm on that Vagrant box that I created for 540. So as part of creating that box that I uploaded to the Vagrant site, I tricked up that Etsy skeleton a little bit. Now that I'm thinking it through, I'm not quite sure why. Because it seems like I'm being a bit of an asshole, because you get it and it's like your own virtual machine, then you create your own users, and then the arrow keys still don't work, right? I'm not quite sure what my original motivation was for that. I think part of it might be that there's a tool called Packer which automates the building of machines, right? Which is the equivalent of you throw in a CD or virtually you mount an ISO and you install Linux from scratch kind of thing, and you have to plug in choices along the way. So I did that with Arch Linux, and Packer is a tool that allows you to automate that. So rather than me creating this virtual machine and then uploading it to Vagrant and then having something be wrong with it and then having to redo the whole thing over, that kind of headache, you just kind of change up the script and rerun the script. It regenerates the machine that then it can be uploaded.
Packer's essentially just like a JSON file.
Yeah. And so anyway, so I think where this is coming from is I originally had some of this in a system administration class, and I think I copied that stuff over, and that must be where that's from. Okay, so yet another class you can take with me. For those of you, I know that many of you are closer getting there to graduating, and I'm sure that you all don't need yet more elective courses, but if you're around for the summer, 344, you get some good stuff out of that course.
Are you going to record that class?
Yeah, I guess you can blow me off and just ask for a link to the playlist. Yes, I'll be recording everything. It's very much, there isn't going to be as much talking as you might expect, because it meets for 3 hours a day, 4 hours a week, or 4 days a week, and the last thing I'm going to do is talk for 3 hours a day. So I do a lot of just kind of setting the scene and then throwing projects at you to work on, right? So there's a lot of learning just through actually doing projects.
I'm in it right now. Do you guys teach the same class?
No. No.
Is it a 6-week course?
It's yes, it's a 6-week course. So, and I'm sorry, it is, even if you're halfway considering it, then my next apology is that it does start at 8 in the morning, so it goes 8 to 11 in the morning, and I know a lot of us aren't morning people. I'm actually not a morning person, given a summer vacation, right? I'm waking up at noon kind of thing, but I do like getting the course out of the way early in the morning and then having the whole day rather than having it kind of cut in the middle of the day. So that's why it's early. Yeah, so anyway, and enough about that. I guess I should talk about whatever we're in here for, huh? We are in here for, let's see, 2019-03-28. All right. Talking about signals. for the project. I did update the write-up for the project, really minor tweaks, but if for some reason you actually downloaded that PDF, download a new copy of it. And I also uploaded a couple files, which we'll be looking at a little bit later today. As based on the overview from last time, we need to deal with message queues and signals. So I wanted to start by talking about signals. Has anyone done any work with signal handling? Or did you do that in a different course? OS?
Yeah.
What did you have to do?
It was the tiny shell. So like you build the tiny shell and like it so it's basically like like a prompt, and you type a command, it parses it,
Right.
execs off the thing, and then if you had to like kill it, it sends it off to all its children and whatnot and sleeps.
So, did you have to write a wrapper around kill or something? Did you make kill a shell command?
You just use the regular kill command and then just signal handlers.
Right. So at a coding level, you're calling the kill system call.
Yes.
Right. So then when you're sitting here, if I pretend this is tiny shell, did you also implement something at the shell called kill? How do you? So what I guess what I'm wondering about is why did you have kill? Why would you have to send signals to another process?
Like cache the signal that in order for it. So like if
Well, what's the motivation for sending a signal? What's the motivation for sending a signal in this project?
so you can communicate between two processes.
This is just testing it.
Communicating between two processes. So for tiny shell? So what?
Oh, sorry. I would like run tiny shell and you'd run programs from tiny shell.
Yeah.
And if you like cancel those programs in your tiny shell code, you'd have to like throw the kill to it.
Okay.
So like if you put it like it'll put something else and then it'll put that job in the background, and then if you want to like kill job 2.
Oh, okay. So your tiny shell supported jobs then,
Yes.
and you could. So you're
Yeah.
using signals to stop them and run
You
them.
have to deal with the whole job group.
All right. So do you remember the overview page on signals then? Did y'all look at man pages in this class?
Yeah.
Where, if I wanted to learn about signals, where would I go? In Joe,
Signal.
do you know what section it would be in?
2 or 3. No, 1.
So if I type man signal, this is in section 3, so it'd be a library call. Let me see if where is the money quote
Doesn't
here?
that just define the signal handler?
Conflict. I'm looking for. All right. So this is, lest you type man signal and you didn't implement this system call, I trust. Okay, and the reason is this note right here. So signal's kind of a more historic interface, and it's generally encouraged for you to disregard it and not use it. Instead, use sig action. All right, so in this case, section 3's got a specific function call. Where can I find overview pages? We had it there's some overview, I think, if I recall correctly.
7.
Yeah. So looking at this, 7 is just miscellaneous stuff. So there you go. There's your overview. This this shows a lot of the defaults, or it shows the various signals. They have a number associated with them, but you typically use a mnemonic that's been defined for it. What is core? Anyone know? Let me back up. So this is the mnemonic. This is the value typically associated with it. This is the default action, which in many cases, not all, but in many cases, you can change by handling the signal yourself. In the absence of any signal handling, this is the default behavior. So for instance, sigchild is normally ignored. I think everyone's comfortable with term, which would be to terminate. But core actually terminates as well. And an interesting difference in nomenclature that you all have from when I was cutting my teeth is when your programs go south, you describe it as having a seg fault. When I was your age, our programs would core dump. And the reason is that, right here. So here's a seg fault generating that signal, and what core does is it actually dumps a big binary file, which is the state of the process, so that you could actually bring it up in a debugger and find out what had gone wrong, right? And by default nowadays, the generation of that file is suppressed. You actually have to turn it on. Whereas back in the day, it would normally generate a big core if it seg faulted. So, I mean, this is not important to the discussion. I want to say it's that there's that it's like a U limit that you can set that lets you generate that lets you turn that feature on so that you get the core dump. I'll leave that for one of you to tell me what it is, so I certainly don't remember. Just a little poking around will reveal that. Anyway, so that's the difference between just simple termination and core. What is sig interrupt from the keyboard? Yep. What about this? Quit from the keyboard. Anyone know what that keystroke is? It is not Control D. Control what?
Control P, like pauses your terminal or something.
Control S and Control Q would pause scrolling and allow scrolling to resume. And those wouldn't be signals. Those would be captured by the terminal. All right, so let's see if I can run a quick program. I want to say
104.40.
Let's do a man on sleep. Wait a minute. What the hell is that? Right, apropos, it's not working. Oh, that's strange. I could have sworn I tried doing that in here. What did I do? Oh, I forgot the exclamation point. All right, so I wanted to bring this up because I wanted to figure out which header file I needed. All right, so Control C will break that. Sig quit is Control \. So if you ever have some program you're running and Control C isn't responding because the signal is being handled, then do Control \/ to break out of it. All right, so you all want to help me write a signal handler for SIGINT, the interrupt signal? So let me go. What's the function call that you all are using to set up a signal handler? Anyone remember?
Signal.
Not signal. That's the one we don't use. But although we can find what we want by going there. Right, so if we go,
I guess sig action.
yeah.
We use signal. Pretty sure. Were you the OS boss last one? Pretty sure we use signal.
You just use signal?
I think so, yeah.
Ooh. Sig action, all right? According to this, you want sig action. All right, so let me bring this up. Let me type, yeah, I'll do it here. Man sig action. Include signal.h. Let me just grab this whole thing. Let me quit out for a moment. Let me just dump this somewhere so we can stare at it. All right, so it's going to take 1, 2, 3 arguments. This is the actual signal number, and this is the one for which we can use the mnemonic. So what I want to do is I want to create a signal handler, or more generally, to be faithful to the name of this function, I want to create some sort of action to occur when a particular signal is generated. I want that signal to be the interrupt signal. And now I've got this. So this is a structure, and I just need to go back to the man page to see that. Structure sig action includes at least these following members. Is there a better? That's going to be hard to copy and paste. Well, let's see. All right, this is going to look wonderful when I paste it. I suppose I could just bring it up in another window and type what I see, but I'd like a challenge. So if I try :read cat. There we go. So let me throw this up. Boy, that's all screwed up. I guess that's what it should look like. I have to create one of these structures. I'll create it. Where's my main function? All right, help me create the structure. Like if I said, okay, help me create a string. That's what I'm looking for, a declaration. What? Huh? Yeah, you can call it whatever you want. Let's call it SIG. Right? There's no reason not to, right? All right. So what we have to do is we have to fill up this information here. So this first thing says it's a pointer to a signal catching function. And the signal catching function is, the function is not going to return anything, and it's going to take an integer as an argument. So let me go ahead and write that function. It's not going to return anything. It's going to have some name. I don't know what we want to call it. Handle the interrupt. And it takes an integer. Now the integer that it takes is the signal being sent. And the motivation for having that is so that if you wanted this one function to handle a bunch of different signals, you could do something like switch on signal case sigin colon, right, do stuff like that. However, I prefer the route of just dedicating a function to each signal, so we will only use this function with sig interrupt, which means that I can totally ignore this variable. Now a little trick, which you may not be aware of, is it's actually legal code for me to do that. That's emphasizing the point that I won't do any, the input parameter is still required, but it's emphasizing that I won't do anything with it because I have no name attached to it. All right. Oops, there I go, all sorts of typos. Okay, so the first thing we have to do for sig is we have to set the SA handler equal to handle this interrupt. Yeah. Note that, so some of you may be more comfortable with actually putting that there to be taking the address of the function, but actually merely leaving off the parentheses is sufficient information for the compiler for it to use the address of the function rather than invoking the function. This is absolutely the same thing. You get the exact same result by doing either one of those. I'm accustomed to leaving it off, so I'll just leave it off. All right. The next one, samask, is the additional set of signals to be blocked during execution of the signal catching function. So let's look at a use case where, let's say that this takes, all these things take microseconds or milliseconds, but just for us to mentally easier visualize this, let's just say this signal handling function takes 2 minutes. So I hit a Control C and I jump to this function and I start executing it. About 30 seconds in, I hit Control C again. And based on, without any other information, then what would happen then is it would go back up and rerun this function from the beginning. Right now I've got this thing queued up twice. If I keep hitting Control C before the 2 minutes are up, I keep going back into this function, and eventually these are going to all have to rewind out. So what the mask does is it blocks additional signals from occurring. It doesn't prevent them. So the key word here is block. So that means that, let's say that there's a sig hang-up sent while I'm halfway through this 2 minutes here, and I have set the mask to block sig hang-up. Then what happens is once the 2 minutes have concluded and this function ends, then that signal is unblocked and it is sent to the application, and it'll jump to that signal handler or quit, whatever the expected behavior for that particular signal is. So that's what the purpose of the mask is. In our case, we're not too worried about it. One thing that is always default is that the signal itself is part of this mask. So the example I gave, where if I keep hitting Control C, it keeps jumping back into this same function. By default, the signal you're handling is always blocked. So you'll never re-enter your own signal code. Okay, it'll complete, and then it'll release the signal, and it'll run it again a second time. The thing about this, though, is we do need to empty it out because of this reason. Integer x, cout x. If I ask the question, what does x print out? The answer is I don't have the slightest idea. There could be anything in that memory. Same is true of this. There could be anything in that memory, which means there can be anything in samask. So we have to specifically clear it out. Now what would be nice is if we could say sig.samask equals 0. Unfortunately, that doesn't work because this is not a mask in the nice way that we've been using masks, meaning that you have a bit for one signal, another bit for another signal, and it's just simply if you turn off all the bits, you turn off all the masking, right? And the reason that isn't the case is if we look at these signal numbers don't follow bit patterns. So they actually have a function. They don't show it here. They actually have a set of functions for setting this mask. So signals that you add, that you remove, and what I want to do is call this function because that function is going to initialize the signal set given the set to empty, right? With all signals excluded. So that's what I want. Because, so that for our project, when we have, let me see, maybe I can actually show it off. I gotta remember where. Okay, what we're going to use is we're going to use signal handling to send messages. So when I say, hi there folks, a signal was generated on this side that caused this to examine its message queue and grab the message and display it, right? Actually, this example isn't holding totally, but note that also every time I move, every time 2 moves, it's sending a signal over here to tell it to redraw its map. So you can have a situation where it's in the process of handling a message and it's okay to redraw the map while it's doing that. So it would leave the message queue processing code to go redraw the map, and then it would come back and continue processing that. So there's no requirement that I need to block those signals. It's fine if they're hitting each other on the toes. It just causes one to pause for a little bit while it runs the other, and then it returns.
If it blocks a signal, that's gone. That signal is gone forever, right?
No, it's not gone. It literally is just queued up for when the other handler finishes.
Oh.
Okay. So it was sig empty set. And sig empty set just takes this right here, which is a sig set t pointer. And if I look up here, samask is a sig set t. So we just need to pass the address of that. So that is the address of that. Why do I have to send in the address? What if I didn't? What if the function call, let me do the prototype for it. Actually, let's bring that up. Let me copy it right here.
So it's like kind of passing it by reference?
Yeah, that's exactly the reason. Because what if I didn't have a pointer? Then what can you say about this set variable?
You just generate a copy.
Set's just a copy of the structure, right? We need to modify the actual contents of the structure in our main program here. All right. So we have to clear that out, and then special flags to affect the behavior of the signal. We're not interested in any of that. Fortunately, it does obey kind of the bit masking behavior rule stuff, so it's sufficient to say sig dot SA flags equals 0. We're good there. And then we need, let me see, what's the other thing we needed? I guess that may be it based on this. I want to say there's something else I'm missing. All right, I think we'll leave it at that then. So I can go ahead and delete this stuff.
Why does it take two signal catching? Why are there two different ones?
You can use one or the other, not both.
What's
Pointed.
one of them takes an extra two extra parameters.
Right. And so you just have to, man. All right, so so note the storage occupied by these two may overlap, and a conforming application shall not use both simultaneously. When they say they overlap, what that means is these are probably a union. All right, there's only one pointer in the structure there, and it's either this, you're either using it as one representation or the other. And I believe it's primarily to fill up that pass structure, I believe, with the signal information.
So you said it blocks itself by default. Would that not be the case to empty the mask?
When you do sig empty set, it will not empty the signal you're handling. So I have to say that without looking at the reference, I can't tell you precisely what the different version of the function handler would do. Let me see. Maybe this is it right here. So there you go. I don't have anything to add to that. All right, so we're going to handle it. We've got, this was just showing us what the prototype to that function is. Oh, we still need that because we're in the process of doing that. So we've got the signal, we've got the address of this structure that we've created, which is CYG. This argument here it'll give you the original handler information. So the reason you might provide this is, I might copy this and call this orig. Right, so there may have been some parameter set up previously in it, and what you want to do is you want to temporarily throw in your own handler and eventually return it back to the way it was. That's why you would use the original, is to get that behavior out of it, or being able to return it back to its previous state at some point. We're not concerned about that. We're going to put in a handler and we're good. So you can just put a null pointer in there for that third argument. I think that'll do it. I think that's all there is to it. Let me see. I got my while loop. All right, whenever I try to interrupt, it should be calling handle the interrupt. Whoops, I lost something, didn't I? Is that right? I forgot what it was.
Yeah, so you can see flags.
That's say flags, thank you. I knew that was wrong. All right, now I can get rid of that. So let's see what we got. We have our handler function. All it does is print a little message, and we initialize the structure. There's the money function. Control C. And also as kill. Oh, we need to figure out the process. So I could go PS AUX. Oops. I'm sure there's a better way, but this is stop that. Sorry, sometimes I get in an argument with myself. Pipe into grep a.out. That would be 1527. This is my grep. But a better way, so that's how I can get it, and then I can send a signal to it. But what I'll do is, what should I do to kill this program? Control backslash, there you go. What I want to do instead is, why don't we just print out the process ID right here at the beginning. What's the, say that again?
Is it get paid?
Let's look at the man page. What header files do we need? Unistandard.h. I think we already have that. I do, so we're good. And now I come over here, and the inappropriately named function call. So this is a shell interface. This is actually a system call. If I type man, let me copy that before I lose it off screen. If I do a man on kill, if I do man on kill, I'm not going to get what I want because I get the shell command. So I look at section 2 of the manual, and what you do is you provided a process ID and the signal that you want to send. So you can program, this is how you're going to programmatically send signals to the other processes, the other gold chase processes. We'll use the bash interface, and it has an option -s right here to provide the signal. So I can say kill -s sig interrupt, and then the process ID. Yeah. All right. So that's that. What's going to happen is I talked about this a little bit, but let me go ahead and bring it up in the write-up. All right, this is the original form. You want to expand this structure with 5 more integers, one for each of the possible 5 players. And rather than integers, the if you wanted to be absolutely correct, it's PIDT is the type that represents a process a process number. If a player's not playing, then just set the integer to 0, right? You have an array of 5 of these in this structure. So when you determine you're the first player, you go ahead and make that first element whatever your process ID is. When the second player comes, they see that the first element is non-zero, so they go to the second element, they see that it is 0, right? So this is where you walk through to find the first available player. Put your own process ID in the first available player. When you quit the game, you go back into that array and you reset your element to 0. So when you move your player, you hit H and you move to the left, assuming you haven't hit a wall, you do your draw, you do your some wait and some post, you change the shared memory, you redraw your map, and then you go through that array of 5 elements, and for every other player playing that's non-zero, you send a kill call to them, right, giving the number in that array. And the question is, what signal do you give them, and what does the signal handler do? The signal handler is just going to redraw the map. The signal you probably want to catch is, anyone have any recommendations? Yeah, so there are 2 signals here that are dedicated for our user-specific needs, and we'll use SIGUSER1 for that. So that's how that's going to be implemented in the third part of the project. I said it last time and emphasized it. Let me re-emphasize it. Let me see, do I talk about the order to do things? No. Probably the very first thing you want to do in this project is remove this from your structure and add the array of 5 elements, and then get the project working where instead of flipping bits on this, you're either interrogating that array or setting your PID to that or setting it to 0. Make that change before anything else. Whatever you do, don't leave this in there. All right. So SIGUSER2 then is going to be used for message queues. Now with message queues, the signal handler is going to, of course, it's going to interrogate the queue, it's going to grab any messages on that queue, and then it's going to display them. And that information is contained in here. The way the signal gets triggered is a little bit different, excuse me. For redrawing the map, you have to specifically go to all other players playing and send a signal to them to trigger that event. For message queues can be configured such that when a new message appears on the queue, it automatically generates a signal for the process that registered for it. Now let's think about what a message queue is. It's a resource that's global to the machine, meaning theoretically you have some application with one message queue out there and you have 30 different processes all talking to it, right? So what happens is on a process-by-process basis, you can register to be interrupted by a signal when a new message comes in. So the way the game will work, as I said last time, when you fire up your game, one of the initialization routines will be you create a message queue for yourself that is read-only, because you're only interested in reading from it. And then you register for yourself, your process, to receive a signal when a message comes in. And it's a little bit quirky in that you register to get a signal when a message comes in, but then once a message comes in and it triggers a signal, that behavior is erased, and you've got to tell the message queue all over again, please re-register me to receive a signal again once another message comes in. So there's a little bit of extra code you have to do to constantly reapply to receive a signal, if you will. And rather than me lecturing on the syntactic ins and outs of message queues, I have added to this write up here, a write queue and read queue test programs, which I've also got here. And they're basically just, they've got it decked out with comments. So what we can do, I guess I can compile it and run it so you can see what the behavior is. So G++, read queue, that shell RT. Yeah, let me go ahead and do, this isn't going to make a difference, but do that. Do the same for write. Oops, darn it. Oh no, I've done it. Now I get two screens up over here. I do read queue. Let me look at very quickly the source code to read queue.
Sleeping for a second.
Yeah, but I'm awake now. Right here, the MQ name. So just like your shared memory and your semaphores, this is your global resource. And like those other two, there's a pseudo file system where you can find the entry. Okay, and it is not in the same place. So if I look at dev shm, nothing there. Anyone know where I can find it? Okay, so it's in a different directory. Now this Vagrant instance has this mounted automatically. Actually, this is when I did Arch. Arch Linux had this directory created and mounted automatically. I don't know if that's a new thing for all Linux distributions or if that's just something Arch did. A couple years ago, I think like on Ubuntu or something, you actually had to create. If you looked at in the dev directory, there was no MQ directory, so you would actually have to create a dev MQ directory, and then you would have to actually mount the pseudo file system onto that to see this. So we can talk about that if that's the case for you. If you don't have this, it's just going to be something like mount -t MQ is the type. I forget. It's going to be something like that. That's pretty close to what you need.
That is described in the PDF you provided.
It's described in what?
In the PDF that you provided.
It is. All right, there you go. I knew I provided that for a reason. Okay. So just keep that in the back of your head. If you don't have that directory, you'll have to do a little extra work to be able to see it. I guess we're here. Oh, it's already done. Let me run it again. And write. A very cool fire engine. Yeah, I usually keep a little bucket of kind of fresh wet rags there in case anyone swoons, but
So seems that every second it's checking the message queue every second.
no, it's not checking the message queue every second. It's being interrupted by a signal. All right, we can easily emphasize that. Let me come back here and break out of this. I hit Control-C to break out of it, and it said cleaning up message queue. So what did I also do in addition to the message queue code?
SIG interrupt handler.
Yep, created a handler for SIG interrupt, and what that handler does is, oh, there it was. I close it and I remove it.
Is FT the file stream?
Yes, yeah.
And maybe we should also create a SIG interrupt handler in our goal chase programs. If someone's playing the game, hit Control-C, then another player is playing. That player bit is still inside the shared memory.
Yeah, so it would be good to handle sig interrupt and clean up and quit gracefully. Absolutely. All right, so let me recompile that. So my motivation for the change was to put a much longer sleep in there so that I could go ahead and emphasize that I am doing this by signal interrupts rather than at the end of a sleep cycle. Also, an interesting thing to note is this is true of a lot of system calls, is that if they're interrupted by a signal, they don't re-enter the system call. Note that it went on to the next sleep, right? It didn't go back to finish the 15 seconds of sleeping that it was doing. This has a huge impact on us. I don't think it's an issue on this project. We'll see. On the next project,
Say that again. So it was in the middle of a sleep. It received
a signal,
and then it didn't go back into.
It doesn't re-enter. It doesn't re-enter the system call.
Is it kind of like the equivalent of like typing continue in the loop? It just goes on to the next iteration.
No, well, I'm speaking specifically to a system call. So let me finish the thought, and it'll make it clear. All right, so this is write, which we all know and love. And the key is in the first phrase of the first sentence. Well, basically, read the first two paragraphs.
It might not write out the full what you intended.
That's right. So you can give it a buffer and make this size 3 megabytes, but there's no guarantee it's going to write 3 megabytes of bytes. It's probably going to write half a dozen, and then it's going to get interrupted by something, and you get what you get back is 6. So you actually have to write code to ensure that the entire output that you want to write is written.
However, it's convenient that it actually returns us the number of.
Yeah, it's not only convenient, it's required. Otherwise, you couldn't create any sensible application unless you confined your bytes to writing 1 byte at a time. This is completing the thought, right? The idea here is write gets interrupted by a signal. It doesn't return and finish the write. The call just ends. And that's the same with sleep. The call just ends. All right. So I think we just about have all the information we need to code up this project. I think that your job is to play with that message queue code and either via Piazza or come to class with questions. And I don't think this project's going to take too long. Thinking like next week to do it. Okay. Any questions at this point?
Seems that if we have some kind of not system call but user code, when it receives a signal handler, it goes to the signal handler and then it returns where it left off. Otherwise, if we would send a signal to the main and get the signal handler, it would just end the program. Is there any reason why
No.
system calls are treated differently than user functions, speaking in the user space? That they don't continue if we're running write and it.
Because the state of the system may have changed. You're right, the kernel is just managing a bunch of different processes, and I would say that there would be some question as to system integrity if it had to be keeping track of all that stuff. Now keep in mind that this is a real issue. Historically it has been a real issue. So let's look at man dupe 2. All right, this is the money paragraph right here.
Automatically closes the previous file descriptor and duplicates it in atomically, meaning in one operation.
Right, meaning that you have no fear of a signal interrupting that.
Maybe it's just one instruction.
Well,
A single hardware.
Well, in this case it isn't. It's doing multiple things.
But
But Dupe 2 came about because of the difficulties of having system call. Here it's referring to race conditions, but the principle kind of is the same, is that there's some things that the kernel, in order to be able to have application integrity, the kernel does have to ensure that certain function calls or certain system calls are not interruptible. Yeah.
Can you broadcast a signal to like all processes?
Mm-hmm. You can.
broadcast a signal if it's negative.
Like if the process ID is negative.
If the ID is less than -1. In the process loop.
So should we be trying to implement group IDs? Oh wait, no. We're not 14.
I read somewhere that when you do Control-C, it sends the negative version of the signal interrupt. So if you have a process which has children, they inherit the process group, the group ID. How we have our other test program, and if you're forking off children, and at times you hit Control-C, it kills the gold chase processes too, because they're in the same group.
Right. Yep. Anything else? All right, so go ahead. I need you all to do some hacking away between now and Tuesday so that we can have meaningful conversations on Tuesday. All right? Okay.